Before starting to understand the interrupt, let's first understand what is the need of interrupt. What was the reason we introduced the idea of interrupt in our embedded system? So you understand, at a time we have multiple devices connected to our system or the machine. Let's say you have desktop, you might have keyboard connected to your machine and mouse connected to your machine, and you have display connected to your machine. Okay, and Linux kernel, you can understand the core component of our operating system, who has the responsibility of managing all these hardware. When I say managing all these hardware, it means at a time if any device make any special request to Linux kernel has to basically address that request and has to provide that service to the hardware. Okay, so you can understand the scenario here is we have CPU. Okay, and then we have our Linux kernel here. Okay, then we have here display device, let's say. Now you understand the scenario here is, let's say Linux kernel basically wants to publish some data to this display device. How basically Linux kernel can do that? One way of doing that is Linux kernel will ask CPU to write the data to this display device, but there are chances like CPU speed can be bit high than this display devices. Okay, so you consider a scenario, Linux kernel basically start writing the data on this display, and it is basically going to wait till your data basically is written on this display. So this waiting period will be an extra overhead on your system, because your device operates at very low speed as compared to your CPU. So it will take a lot of time for updating this data from kernel to the display. So this is the time consuming process. And other scenario, you can assume you have keyboard. Okay, so at any point of time there can be a user event on the keyboard. So whenever user will enter any key on the keyboard, so keyboard basically request Linux kernel to handle the key press event actually. So how it can be done? So one way of doing that is Linux kernel will keep on checking whether there is uh, any key event happened on the keyboard or not. So but you understand here is, if Linux kernel will keep on checking this scenario whether there is some event on the keyboard device or not, so it will be basically consuming lot of CPU cycles, because kernel has to again and again checking this keyboard event whether it's happening or not. Okay, so this process of keep on checking at the time of predefined interval is called polling. Okay, so polling, basically our Linux kernel will keep on checking the status of the devices connected to the to our processor, and it will check whether there is some event generated from these devices actually. So if kernel has to kernel must be doing some task, and then it will stop its own task, and then it will check the status of keyboard and then display. So this will basically add the overhead on the system, and overall it will slow down our system performance, because our kernel will spend most of the time polling for the devices event actually. So this was the very bad approach for handling the communication between devices and the processor. So embedded system experts come up with the concept of interrupt. So what does interrupt means? Interrupt is an asynchronous event which can happen at any time. If any device wants to basically basically request some services from the Linux kernel, they can send an signal to the CPU. Okay, so CPU will basically notify the same event further to our Linux kernel. So Linux kernel now will basically handling that event which is coming from this device. So basically interrupt is kind of mechanism which enable hardware to signal to the processor.